Hello and welcome back to GeeklyEDU. Here, your math geek talking and continuing with another curvilinear coordinate type, spherical coordinates. We have now covered polar coordinates and cylindrical coordinates. If you haven't seen those videos, don't miss them. Spherical coordinates can help us, for example, to model the geometry of a cone or study how planets, stars, and galaxies move, and even the eigenfunctions of the Laplace equation. As the name of the coordinates tell us, spherical coordinates are represented with a sphere, and we can understand their geometry comparing them with the well-known Cartesian coordinates. Let's begin drawing a point in space. That point doesn't exactly depend on the coordinates, because we use the different coordinate systems to describe the position of the point. When we use Cartesian coordinates, the point is located in x, y, and z. But in spherical coordinates, this point is in r, theta, phi. Here, r is the radio, theta is the polar angle, and phi is the azimuth angle. Now, we will have to use trigonometry to find out the relationship between Cartesian and spherical coordinates. If you don't remember quite well the trigonometric identities, watch the trigonometric functions video. We will start here with the upper triangle with a theta angle. In this one, the hypotenuse is r, and therefore the component in z is equal to r cosine of theta. The upper line is r sine of theta. If we pay attention to the orange line, this has the same value of r sine of theta, and it will help us understanding the triangle in x and y with a phi angle. Using again trigonometry, the y component will be the hypotenuse multiplying sine of the angle phi, but the hypotenuse in this case is r sine of theta. Then the y component is r sine of theta sine of phi. And finally, the x component will be the hypotenuse r sine of theta multiplying cosine of phi. Most of the times you will use the previous formulas, but in case someday you must transform from Cartesian to spherical coordinates, you will have to use the same logic as before, trigonometry. By Pythagorean theorem, we know that the norm of a vector is the root of the sum of its components squared. In this case, we want to know r, and the components of r are x, y, and z. To know the component theta, we can start with the formula cosine of theta is equal to the adjacent cathedus z divided by the hypotenuse r. We need to substitute r in terms of x, y, and z, and then clear theta. Finally, to get the phi component, we use that the tangent to phi is equal to the opposite cathedus y divided by the adjacent cathedus x. Using the equations of transformation of the coordinates from spherical to rectangular, we will convert the spherical coordinate 5, p divided by 2, pi divided by 3. From the cheat sheet that you can get at the end of the video, trigonometric functions, we know that the sine of p divided by 2 is 1 and cosine of p divided by 3 is 1/2. We obtain that x is equal to 5 divided by 2. Substituting in y, now the sine of p divided by 3 is the root of 3 divided by 2. Getting that y is equal to 5 times the root of 3 divided by 2, and z is equal to 5 divided by 2. Take a screenshot of this cheat sheet and remember that the most important thing in math is not memorizing things, but understanding them.
Thank you for watching our video. Stay tuned for more math topics and don't forget to subscribe.